All right, y'all. What we're going to do is slow it down a little bit. I was talking to our other Algebra 2 teacher, and we discussed the fact that we think, hey, the three equations, three unknowns, is a little bit too tough for us to start with. Our Algebra 2 book starts there, but we need to review, we think, a little bit more of the two equations, two unknowns. So we talked about these on Friday. All right, so let's talk about the first method that we can use to solve a system of linear equations. Remember these equations. You plug in an x, you can find a y. These are all functions that we're dealing with. Each x gives you one y value. And these equations in this system, what we're looking for is the ordered pair where the x's and y's are exactly the same value. And again, as a reminder from Friday, if we graph the blue equation, y equals 2x plus 4, that shows all the ordered pairs that make it true. Now the nice thing is, this equation and the other one in green, they're both in slope-intercept form. So we can just, remember our y-intercept where it crosses the y-axis is 4 in this case. Let me do it in blue so we can match the colors here. So the y-intercept is 4, and the slope then is whatever's right next to x. In this case, that slope would be 3, or 3 over 1, which means to count up 3 and go over 1. So I'm going to count up 3, go over 1. It puts me at, looks like 1, 7. And I'm going to count a few more points. So I also went down 3, back 1. That's the same thing, up 3, over 1. Just counting. Going down 3 makes it negative 3 over negative 1, which is still equal to a 3. So we can count down and back as well. Let's go ahead and draw in that line here. So there is the equation graphed. And that line again represents all of the solutions to that blue equation. Again, I need to draw some arrows on these things to say, hey, this line goes on and on forever. So let's graph the green one now. Y-intercept, negative 3, because we got to see that negative right there. I'm going to mark negative 3 on the y-axis. Slope is negative a half, which means down 1. Remember, this is rise over run. And because the rise is negative, that means go down 1. And then over positive 2, negative slope, it's going to go up and to the left, just like it should. So down 1 over 2, down 1 over 2. We'd also go up 1, back 2. Up 1, back 2, like so. And let's draw that line in. So he is right there. And so the blue line is all the solutions to the blue equation. The green line is all the solutions to the green equation. And so where do they share a solution? And that's just that point of intersection right there. So you can just read it off the graph if you've done a good job graphing. That's at negative 2, negative 2, it looks like. Let me erase my arrow to make sure of that. But yeah, let's zoom in there and you can see at negative 2, negative 2, they share a solution. And so that's the answer to the system. The answer to this system is negative 2, negative 2. Now, we call this in mathematics a consistent system. It should be an A, I believe. Consistent. So consistent systems have at least one solution. And this does, and it's that ordered pair that they share. And that's all you have to do. Graph each line, find where they intersect, and that's your answer, that ordered pair. Now, not all systems are consistent. Hey, if we can just graph the two lines, where do they intersect? That's our ordered pair, that's our solution, consistent system. Here I've got another pair of equations. Again, these are in that slope-intercept form, so we just have to mark the y-intercept for the red one, negative 4. Count his slope. Remember, slope is up 3 over 2, right there, 1, 2, 3 over 2. Show you with my pointer, up 1, 2, 3, and then over 2. to 3 over 2. Okay, so I'll just mark a few more points so I can graph it accurately. I also go down 3 and back 2. Let's draw that line in. Again, trying to make him as accurate as I can. So for this, you might want to use a straight edge, a ruler, edge of your book, edge of your notebook, just something to make him straight so you can read the final answer. Let's do the green equation. Y-intercept positive 5, so way up here. And his slope is 3 over 2 also, up 3 over 2. So I'm just counting the same way, down 3, back 2. Down 3, back 2. Let's draw him in. Now this would be an example of what we call an inconsistent system. Remember, we're looking where the two lines cross. These two lines do not cross anywhere. So this is an inconsistent system, which means they never intersect, which means there are no solutions to the system. There's plenty of solutions to the green equation, so everything that's graphed here, plenty of solutions to the red equation, but because they are parallel, they have no solutions in common, and therefore it's called inconsistent. Now, you actually did not need to graph this one, because if you remember from earlier in the year, we talked about slope and parallel lines. If two lines have the same slope, they are parallel, and therefore they're never going to intersect each other. Now, they have to be different lines, so this one was at, its y-intercept was -4, the red one was, and the green one was at +5. So we just knew they were not the same line, but they were parallel, which means they will never have any in common solutions. Let's look at another example here. Hey, what if our ordered pairs are parallel to each other? Inconsistent system, no solutions. You could also write the null set for that. All right, this one's a little bit tougher. We have a system, two equations, okay, but they are not in slope-intercept form. So the best thing to do here is put them in slope-intercept form. Okay, so I'm going to separate these two just a little bit so I have some space to work. To get them in slope-intercept form, we're just trying to get the y value alone. So I'm going to subtract my 2x. Notice how when I subtract it, I'm going to put that -2x on the right-hand side, right behind the equal sign. That's important, because we want y equals mx. So our mx has to be right behind the equal sign. We almost have y alone, but we got to get rid of that negative. So let's just divide everybody by -1. Everybody by -1. Y equals 2x minus 3. Slope-intercept form, we can graph it. Let's do the same to the red one. Subtract the 4x to get it to the other side. 4x minus 4x is 0 right there. And we get -2y equals -4x plus 6, parking the 4x right behind the equal sign. And then we'll divide by -2 to get y alone. -4 over -2 is 2x, positive 2x, and 6 minus 2 is -3. And here's a big thing to look for. These two equations are identical to each other. You can have a system where both equations turn out to be the same. They may look originally different from each other, but after you put them into the same form, they end up being identical. So I'm going to graph the green one. Y-intercept -3, up 2 over 1. And we'll sketch him in there. Pretty much like that. I'm going to graph the red one. Not going to be a whole lot different because it's got exactly the same y-intercept. Up 2 over 1. Let's draw him. And so these two lines overlap everywhere. Now, unfortunately, we can't just say the answer then is, hey, they share every single point, because they don't. They only share the points that are on the line. Which line? It doesn't matter which line you choose, but you just say, the easy way, I'll just write it in people language, all ordered pairs on the line, and you can choose either the green equation up here or the red equation, but the red equation has smaller integers. I'm sorry, the green one has smaller numbers. So you just say on the line 2x minus y equals 3. Okay, so every ordered pair that's on this line is also on the other line, and therefore they share all those solutions, which is an infinite number of solutions. Now, in math parlay, we write it this way. We say all the ordered pairs, using that set notation there, that are on the line, and we just go 2x minus y equals 3. So that's our solution set. Now I've got one more example. So we've seen now, the two lines lie on each other. It is still considered consistent because there are solutions, at least one. And we can write our answer in this fancy math way. And then here's our last example. Let's go ahead, put these in slope-intercept form. We'll graph them and see what happens. So I'm going to do the black one here, subtract my 2x. Negative 3y equals negative 2x plus 9. Divide by negative 3 to get the y alone. Y equals 2/3 x, and then 9 divided by negative 3. Y-intercept negative 3, up 2 over 3. Up 2 over 3. Down 2, back 3. So let's go ahead and draw him in. Let's put some arrows on him. Let's do the red one. We'll subtract the 4x. Negative 4x plus 5. Y-intercept is 5. Down 1, 2, 3, 4, and back 1. Remember that slope right there, negative 4 over 1. So its rise is negative 4. Its run is over 1. 2, 3, 4 over 1. We'll do it again. Let's graph this line. Now, in this case, we can see they do have a solution. It's almost impossible to read from a graph. All right. So in this case, we just point to it and say, there's your solution. If we wanted to guess, we might guess. Let me see if I can zoom up here. We might guess about 2 negative, almost 2 negative 2, but not quite there. So this shows you the flaw in trying to solve by graphing. Okay, now if we have a computer, we can actually automate the graphing process using Desmos, which I would encourage you to use to check your answers. Remember, in Desmos, you can just type in the problem in standard form, and it'll graph it. So feel free to use Desmos to help yourself out. This one, we just point to the solution. Now, in today's assignment, all the problems will come out to be nice, even ordered pairs. So if you graph correctly and graph precisely, you should be able to determine each answer very accurately. And that's it for today. Do the homework and you should be in good shape.